we can practice solving.
You guys do note that vocab word because we haven't used it before, but it is something we'll talk about. So what is a radicand? So pay attention, the radicand is what's underneath the radical. So there's a word for the stuff underneath that radical.
So if we put this in our calculator, what is this value right here? I don't know if you have enough time to do that. Is it 961? So knowing that this value, the radicand is 961, how are we going to rewrite this simplified? What do you think, Marshall? How are we going to rewrite this simplified? Okay, but we're trying to just simplify this one, the radicand. Right. We have that value, but rewriting it with that value to help us solve. Like, we're trying to simplify this to help us solve for x. I guess this should be also be like x. Do we have any ideas? So we're trying to simplify an expression. That means that all of these values are the same, right? So if these are all numbers, they can be added and subtracted to combine. And that is what we're trying to do here to get an actual value for x. So to rewrite this, we have negative 11 plus or minus, what did you say it was either? Thank you, 961. And what's 2 times 6? 12. Unless it is a perfect square, y'all can just leave it in the square root, as a square root. Because then it's going to get some kind of complicated number. And it's harder to deal with than some. You can't write. Some of them go on forever. But, yeah, so do you have any questions? I know I probably could have done that a lot better, but
Can you take the square root of 961? Did we try that?
It's 31.
it's 31? Oh, thank you.
Yeah, because if we
Look
even
at
factor it, there's gonna get rational root.
Did you say 31?
Mm-hmm.
Well, boom. Okay, now that is much easier to solve. You see how this is really, really complicated and we need to simplify it down to this to something that is whole numbers to where we can solve? So let's try both of these in the calculator and separate them to solve. So negative 11 minus 31 divided by 12. You'll put that in the calculator. And then we also have negative 11 plus 31 divided by 12. What do we get? 5/3? The first one? What do we get for the second one? What'd you say? They're both 5/3? Okay, that's one. So what's this first one then? Okay, now any questions? So when we have standard form, the quadratic formula It'll always work, right? I wish I asked that. Mr. King, quadratic formula will always work, right?
Yes, but,
It just is a whole process compared, that's why we'd rather
and,
factor or something.
yeah, and also, we have to be careful, because what does the equation have to equal, which is what a mistake a lot of us made for the first two. What does the equation have to equal?
0.
If that equation does not equal 0, you cannot use the quadratic formula. Keep that in mind.
Cool, so when we have standard form equal to 0, the quadratic formula will always work, but this is a whole process, it's a lot easier to factor or do vertex form, that's why it's like the last resort. But y'all need to practice this, and so we just need to substitute the values of A, B, and C into the quadratic formula, and then simplify, and we get our two answers. Or solutions. Any questions? No, sure?
I'll give it a rest for you. That's what I said.
Oh, that thing, okay.
But also, I guess it's time for the agenda? Is that right?
Yes.
Okay. I'm gonna do the agenda, Ms. Bowers leading the rest of this. I just wanna talk through a couple of details, specifically things that aren't on the agenda. First things first though, we gotta always keep this in mind. Why are we here?
To learn social skills.
To learn social skills, which is why we are grouped, right? We gotta learn to learn together. We gotta learn to talk with the people. One of the things that is going to bug me is when we are in small groups, especially during the bell ringer, and we just pick an answer and never talk to someone in our group. Oh, I just guessed. No, guessing's not a valid option. Try. The point is to learn together. Why else are we here? To learn how to think. That's a huge part of what Ms. Bauer's lesson is on today. Make sure we are paying attention how to learn how to think. Thinking through which method are we going to be using. We have learned 3 different methods to solve a quadratic equation. I've just started glancing through the understanding checks, but we gotta learn how to identify which method to use better. And so that is what we'll be doing today and tomorrow. And just learn how to learn. That's an important part. One thing that I forgot about for this class is some of us had not caught up to where we were supposed to be in solving quadratic equations on Mathia. I fixed that at the end of class and didn't get a chance to tell y'all. So if you were not on solving quadratic equations, you were kind of stuck. I have extended, because of that, I have extended Mathia to be due on Wednesday. So you have 2 days to get your Mathia work done, which is important because these are practice problems that we gotta do to be ready for our understanding checks and our tests, things like that. So, when's Mathia due, those last 3 workspaces? Wednesday. If you're already done, bet, you're doing well. If you haven't got them done, take advantage of enrichment time, come to tutoring, do whatever to get that stuff done. The more you practice, the better off you're gonna be. And then Ms. Bauer is leading today's lesson. Mr. Kilpatrick and I will be coming around during small group time to ask questions to help learn. But Ms. Bauer is the leader in the classroom today. And so we have 2 different things, or at least your lesson first, and then if we finish early, I have another thing for us to practice. It's all about what is the best method to solve a quadratic equation. Now, the way Ms. Bauer has structured this is a really good lesson. We worked on it together. However, pay attention to instructions, because if you do not pay attention to instructions, it will be easy to get lost. But if we pay attention to what Ms. Bauer directs us to do, this can be a really, really powerful lesson in learning, 1, the best method used to solve quadratic equations, and 2, that practice in solving quadratic equations. All right.
Okay, so there's gonna be a lot of moving, a lot of talking, a little bit of chaos, that's okay. I'm gonna see, try this out, you know. So, I'm gonna give you all instructions step by step, that way you don't get ahead of yourselves and stuff. So, what we're gonna do is each group, as I pass this out, each group is going to start an equation, so.
Sorry, really quickly, just point of order, because this is bugging me. Guys, there should not be chalk on the floor. Like, there's boxes, put the chalk back in the boxes, it's very simple. I'm about to put out colored chalk so that we can use that once again. When you're done using the chalk, where are you gonna put the chalk?
In the box.
In the boxes, right? I like to keep a somewhat clean room. I am not the most organized person, but please respect the room. Sorry, Miss Bauer,
No,
I
you're all
just
good.
wanted to make sure that we are paying attention to that.
Yes. Okay, sorry. So, you're gonna start at your vertical surfaces, and you're going to start with the equation that is your group number. So if you're group 1, you're gonna start with problem 1. And the first thing that y'all are gonna do for the first round, there's gonna be a lot of rotations, but for just for this first one, y'all are going to simply identify what method to use to solve the equation that you have. Sorry, also that's and write down why. Does that make sense? So you're going to go to your vertical surfaces, write down the equation that corresponds to your group number, and then talk with each other to identify the best method that y'all think is best to use to solve the equation. Does that make sense? Okay, all right, so y'all can get up and get started. Y'all have 3 to 5 minutes to do that.
Hey, Jayla, I got something to go over here.
Also, please write the equation at the top, that way we're gonna rotate to the next group, knows what equation.
Right, so I gotta go over here.
I know, but I'm saying like. We have our. Y'all got it. Bro, what are
Yeah, like spider and slime.
What is Rico? And everything else is getting charged with. And
Y'all got some things.
I'm not even an hour in the club.
Alright, it looks like we're ready.
White bread.
We like
You got made,
girl, that can't run away.
This ain't no lunch. This ain't no cafeteria.
Oh, wait.
A whole week.
Thank you, Grace. Thank you, Ethan. Excuse me, thank you.
raise our hand, what's our problem?
Don't
It's okay, we'll get that later. Oh, you're still writing that down?
Alright guys, so we're gonna go through each group and y'all are gonna be the ones that explain what is the most efficient way to solve the quadratic and why. So where's group one is right here. So y'all have the equation in blue at the top. How did y'all know which method to start with? How did y'all start? And then how did y'all go through other people's work in order to determine whichever way was supposed to be? Yeah, to get it equal to 0, yes. So what method did y'all start using? The AC method? I'm sorry, go ahead. And it worked. So what told y'all that the other ways weren't as efficient as this one? As the AC method? Okay, you could do vertex form, but not because it's an odd number. Yeah, you get a fraction, which most people probably don't want to do with fractions, is you have to, once you get that fraction for h, what do you have to then do with it? To get that value? Right, substitute it back in the equation to get k, and then once you have your equation, what do you do next when it's in vertex form? Right, inverse of the property of inequality. So is that more efficient than the AC method? No, yeah. And how about the quadratic formula? Why didn't you not choose the quadratic formula? Yeah, so the AC method is the quickest and most efficient way to solve it. And you'll get the exact same answer 3 times, or each time, but we're trying to do what's most efficient. Thank you. All right, group 2. Where are you? Y'all group 2? All right, so y'all had this equation, and which method did y'all originally start out using? And did that work? So which one did y'all try next? Is that this one right here? And then y'all got stumped, or Einstein. So what did the next group come in and try? What method did they try?
Can I pause just really quickly? I see a handful of us doing this, but remember the whole point of this is reasoning through like what the best method is, right? So if we're going to study and think through these reasons, what should we do just really quickly? We don't need all the work, but we should probably talk through why we use the method, right? Okay. Sorry, I just want to make sure we're thinking through that.
Sorry. So how did y'all know? Like y'all's ended up changing from what y'all started with and what the last group went with. Why did y'all agree with how the last group finished using the quadratic formula? You didn't agree with them doing this?
I'm not saying they're wrong, but like, that's not what we made it.
Right. So you said that the AC method didn't work.
Let's do the vertex.
Right, so then you tried vertex, and why wasn't vertex? Which is right. So what do you have to do with H once you find it? Right, substitute it back in. Right. And then what do you do when you have A, H, and K? Right, you're writing vertex form, and then do what? How do we solve an equation that's in vertex form? Yeah, everybody knows basically. Yeah, inverse of properties of equality. And then let's compare it to the quadratic formula where they just substituted the values of A, B, and C into the quadratic. Why do you think now that we've gone through why the AC method doesn't work and what to do with the vertex form, why do you think this group decided to use the quadratic formula? Anybody can answer. Just talk about it. It is easy to find A, B, and C, that is true, but is this process more efficient? Like, does it take, well, I guess it takes about time, but as well as. Sorry. Substituting values in, is that easier to do if it doesn't, if the AC method doesn't work? Yeah, and is vertex form a lot more involved and complicated to find than substituting values in? So do we agree that using the quadratic formula is the most efficient way to solve this one? Yeah. Why? I just said,
Because it's the most efficient, and you can get there the easiest way.
right, okay. Do we have any questions about this? Sorry, I know a little bit of a roller coaster, but. Does this make sense? Yes,
Yeah, ma'am.
Okay. All right, so group 3, what method did you all end up choosing? The AC method? Why the AC method? It was. So did other groups try other ways? Did they? They did try vertex. So why did you all say that the AC method was most efficient compared to vertex formula or the quadratic formula? It is easiest, but why? So I just went through the process of going through vector form, vertex form, and the quadratic formula. What'd you say? It is the most efficient. But how did we know that it's the most efficient? Does anybody else know why it's the most efficient? Can you explain? Hey Preston, do you know why the AC method is most efficient? What about this method is different from the other methods?
This is easier to factor.
It is easiest to factor. Is it, how would you go about doing vertex form?
If you do the negative, or if third equals 0, it would be negative b relative to 0. So
Do you know?
there's not really a lot of stuff.
That's all right. Can anybody explain how the quadratic formula would not be an efficient way for this form, or equation?
Because it has factors
Can I
that
get
add
more?
up to age.
To add up to what?
Age.
Not H.
Okay.
Not K.
X.
B.
B.
B. There we go. What were you saying, Aisha?
Just 3, right?
Yes.
Oh, I'm gonna say it ain't gonna see. Oh, I'm tripping.
Girl, the C is 10.
I didn't say something.
Yeah,
I mean, the C is 9.
You just said something.
I mean, the C 9, man.
Yeah, you thought you ate a
I did, and I
Oh,
still
no.
did.
Let's get back to the math. Okay, so let's say we're saying that A and C added to B, and that the factoring, the AC method of factoring is the most efficient. Okay, let's move on to number 4. Where's group 4?
Right there.
There. Thank you. What did y'all start out by saying would be the most efficient way, or what did y'all come up with?
Talk to me.
Girl.
We did a vertex.
So the vertex. So why did y'all choose to use vertex? Like
The
what-
quadratic was easier, but. we did
Okay.
vertex.
So why did you think it was easier once you started out using vertex form? You say you got a fraction?
No, we didn't finish all of them.
Okay, you can look at, this is the point of looking at everybody else's work.
I would say it's a little hard to see.
No, I meant no work the other groups. But, so why didn't you all say the AC method?
Oh, because,
They don't
fact-
add up to be.
Right,
Okay,
so then
girl.
you moved on to vertex. What'd you say? Okay. So then you moved on to vertex form, but y'all weren't the group that did this, so did vertex form work?
We didn't finish it. We don't know.
I think so, if that's in
Mhm.
green.
Yes, yeah. But then, so you're not saying that you agree to use the quadratic formula and give them a solution? So looking at the others, what's your reasoning for why y'all spent it with the basis of vertex form? So do you think that substituting these values in would be easier than doing the vertex form steps to solve?
Yes.
I do, go ahead, actually, go ahead. With whatever you're gonna say with it. I was gonna caution something.
No, you can go.
Okay, I wanna caution you though, guys. One of the reasons why I quadratic formula will always work. The reason why I don't love it is in substituting in, there's a lot of places to make mistakes. There's actually 2 errors in the quadratic formula method. I want you to look at the radicand in the quadratic formula method. What's the radicand? So remember, what do I mean by radicand? The stuff under the radical. Look at the final step. What is it under the radical? What's the radicand with that quadratic formula? Underneath the radical. It's kind of hard to see. At the end. Ms. Bauer, can you circle it? What I'm referring to?
Is that what you're talking about?
Yeah. Someone that's up front, guys. Y'all should be able to see this most easily. What's underneath that radical? Close. That's a -4. Look at the radicand though for the group who used vertex form. What's under that radical? Desiree, you're right there. What's the radicand for that vertex form method at the bottom? Say it louder for me. I can't hear you. No, the radicand. What's underneath the radical? It's 3. Did we get the same radicand for both those methods? That means we made a mistake somewhere. We gotta be careful.
That was their group.
That's okay. Hold on. Hold up. Stop. Excuse me.
I'm just saying.
Tevin, the point is to learn with each other, not to blame
No,
others.
she said who did that. I was telling her that
Tevin, it's okay. It's okay. Excuse me.
Tevin, just calm down.
Hey, guys,
What am I doing?
look at the formula that's written on the board. Where's the mistake in that formula? Because I didn't see it until just now. I corrected one thing. Notice I wrote the green line where that fraction bar is across the entire expression. But look at that quadratic formula. Where is the mistake? If you look at the quadratic formula for group 2, it's supposed to be what? No. It's a good thought. Look at the formula behind Miss Bauer. Compare those.
Oh, it's a piece of trash.
What are you supposed to be subtracting?
Oh,
B.
The -4 AC. Be careful about that, guys. If we fix that, that should make it work.
You should do it
Once you simplify the radical. It won't look exactly right from the beginning, but it'll work. So, once again, quadratic formula, it's easy to substitute in wrong or to write down wrong. You have got to know the quadratic formula before your next understanding check and test. Learn it. Yes, it looks long and scary, Nikki, but don't let it scare you. I know you were like, but Mr. King, you have to learn the whole thing? Yes. Gotta know that quadratic formula, guys. You did say that right at the beginning.
Okay, so realizing that we can make mistakes if we substitute it in wrong, or you can also, well, if this was a minus, you can substitute it in the calculator, put it in the calculator, and get your answer, but realizing that, what way do we think is most efficient? Vertex. Why do you say vertex? Like, why not quadratic formula? about it. What can we do that will
Oh, plug it in wrong,
make
look.
us incorrect? Yeah, we can substitute it in wrong, or if we don't have the equation wrong, we need, or if we don't have the equation, we can write it down wrong and do that. Alright. Do we have any questions? Am I confusing anybody? Probably. You a bit lost? Okay, so we're gonna move on to number 5, where is that?
Over here on the left.
Thank you. Group 5, what way did y'all conclude was the most efficient? You said AC? Why the AC?
Well, first we said the quadratic, but we went back and realized that it was fraction, so the AC method.
So what about using the quadratic formula was less efficient than factoring?
I don't know, but there are factors of -30 to add up to 7, so.
Right, so if we-
can do it.
Sorry, no. If we can recognize that factors of A times C add up to B, and then rewrite the equation equivalent with the terms of B to factor it out, is that easier than trying to substitute it all in that big formula that you also then have to remember?
Yes.
Okay.
Really quickly, I do want to point this out, guys. On your test, I'll go ahead and tell you this. The way the test is going to be set up is, I'm going to give you quite a few equations, and it's going to be up to you how you solve it. But I will require that you use vertex form twice, quadratic formula twice, factoring twice, and then whatever else you want on the others, or something to that effect. And you need to tell me why. Why did you choose that method? So, is it possible to use the quadratic formula on a problem where you could factor? Yeah. Is that okay? Yeah. So just be aware that I will be expecting those different solution methods. So that's something to think through. We just want to pay attention to those details. And then 6 is here on the TP.
Thank you. I do want to mention, though, that multiple ways can work, but most efficient means accurate and in a timely manner. So other things may work, other methods may work, but they may take you a little bit more time. And so it's realizing a little bit of trial and error. What I have done either doesn't work, or it's taking me longer than a different method might. Or it's a little bit complicated, and I'd rather use the simpler method. Is that okay? Okay, so group 6, what method did you all start using, and which method did you end up saying that was the most efficient?
AC method.
AC method. So why not the quadratic formula?
Takes a long.
If it takes too long, yeah. Okay, so why not use convert to vertex form?
Yeah, it took too long too.
That takes too long too. So we'd rather
AC method, it just,
have
and
A
that's the
times
first
C.
one that came to my mind.
What'd you say? I'm sorry.
That's the first one that came to my mind.
Okay, yeah. Okay, so where's group 7? So what method did y'all start out with?
Oh, Ms. Bauer, really quickly, I did want to point this out because we did get 2 different methods finished solving here. Please notice factoring, what solutions did they get? -5 and -1. Here is using the vertex method. What solutions they get?
-1.
Right? So, will multiple methods work? If I use the quadratic formula, what will I probably get? -1, -5. As long as I don't make a mistake, those are the solutions that I would get. So I just want you to see that one case. Notice this one group would not have gotten that. A later group noticed, the purple group, so group 2 noticed, hey guys, we gotta make sure we do -b divided by 2a. So that should have been -3 there, right? If you substitute in a +3, it messes up. The -3 is what you wanted for K, or for H. So be careful with that.
So group 7, what method did y'all start out with, and what method did y'all think was the most efficient?
Started off with A times C, and then apparently I forgot how to factor. So I don't know. So we tried using vertex, and then it gave a fraction. And then we came back and did factor, and that worked.
So why didn't you want to use vertex form?
Because it gave a fraction, and I didn't want to work with that.
Right, what did you have to do with that fraction in order to find the rest of it? So that value is what in vertex form?
What do you mean, the fraction?
Yes. So you said negative b over 2a is equal to what to help you convert to vertex form?
Are you just asking what the h value was?
Yeah.
Okay.
Just say that? Okay. Yeah, what was h?
No, negative
The-
32.
Yeah, the fraction. So we could then substitute, now here, we can substitute back in and find k, and that's a little bit more involved and complicated. So why didn't you try or think that the quadratic formula?
Well, we thought about it and we rotated, and then we never came back to it.
Yeah, they just ran out of time.
There you go, yeah. So the AC method was most efficient because it worked, and so therefore you want to factor in possible things. Probably the most simple way.
Guys, I do want to point out, I have been recording this whole time, going around to each of the groups, so the solutions will be on YouTube, that if you want to go back and not just identify what the most efficient method was, but you actually want to work the problems out and check your solution method, that practice is going to be important for your test, right? Like, it's not just the understanding the concept, it's also being able to put it into practice. So that'd be a good chance to help you practice for your test of working each of these problems out and then checking yourself with those YouTube videos. Huh? The test? Planning it for sometime next week. I gotta figure it out based on the fact that we have ACT next week. I think field day is next week. So we got like a million different things going on. Huh?
We should wait till Christmas, the week after that.
What's the Christmas?
That's the point, we never take it.
I should. You one of those person out there somebody gonna take it. Shut up. I hate folks like me.
Well, we're not here.
Right, and we not.
But you never know, we gonna switch.
Right, it's okay. We're not gonna switch after the test.
Excuse me, ladies and gentlemen, did we say to pack up yet? No. Can you pass out the equations and the graphic. All right, ladies and gentlemen, okay? So we only have a couple of minutes, but I want to go ahead and pass out what we will pick up with on tomorrow, which is very similar to what we just did with Ms. Bauer's lesson, where we are thinking through the most efficient method. I think that we need a little bit more practice before we wrap up with it. And so Mr. Kilpatrick is passing out 16 equations. Excuse me, I'm talking. Okay? Still talking. Excuse me, listen, no. Hey, Shania, I'm talking. Thank you. So, tomorrow, when you walk in, your bell ringer will be to actually cut out these equations, which is why I want you to already have it. And what you're going to do is take the graphic organizer that Ms. Bauer is passing out, okay? And we are going to identify which method is going to be the most efficient. So what I actually want you to do is we have 3 minutes left, so I want you to take 2 minutes. I want you to start talking about it with your groups and identifying which method do you think you would use for each equation. And tomorrow we're going to cut it out and start gluing. So take the next 2 minutes, start writing out those equations, or writing on the equations what method you're going to use. Okay? So start talking about it. Also, it's really more efficient when you just do 1, 2, 3, 4.
Right. Come here, you gonna take
Let me read it. We know what that is.
What's the meaning of that? Do you know who you are?
Start identifying those methods.
The next time y'all ain't
That's how you answer that.
I don't know what's going on with you other people.
Candies?
You've been giving that complete.
Don't come.
Wait.
Go ahead and start writing on here. Just be prepared to roll on 1, 2, 3. Okay? Hey, why do we already have our equations put up? Hey, why do we have our equations already put up?
We talked about it. You can use
quadratic cubes, they're set at 0, and then you use the AC for the other part.
So what I'm asking you to do is I want you to look at these equations and identify what method you're going to use for equation A. What method you're going to use for equation A. We all engaging in the whole class discussion?
And then how we work with social skills, we work talking about it. Social skills is talking about drinking. Don't be like this all week. Don't be like this all week.
You don't like my little?
Thank you, Rustin. Thank you, Grace. Thank you, Z. Thank you, Jalen, Ethan. Okay. Hey, Miracle, when you put the hand up, that's a sign to you and others that we stop talking. Thank you. So, please remember, assignments, finish Matthew solving quadratic workspaces. Everyone should have been pushed to those quadratic equations. When is that Matthew assignment now due? Wednesday. The reason why is your last understanding check is going to be on Thursday. We have one more concept that we're going to start learning about tomorrow, but it doesn't change how we solve quadratic equations. So you need to practice solving those quadratic equations. That's why it's due on Wednesday. That's good practice to help you prepare for the understanding check on Thursday. So if you finish early, you can do practice problems, right, Naisha?
Yes, sir.
So pass your literacy for all. We're going to continue this activity tomorrow. Have a great rest of your day. There's definitely some good learning today, and I appreciate that.
Tell me have a good day. I'm not no wait. What you say? You don't talk to me like that. What you say? I say have a good day. Oh, you been acting like a little wench. Yeah.
Somebody's gonna pick up the
Please call me a witch.
I get why you were doing
Yeah, I don't
it,
even
but like you're going through like, oh, if we get vertex form, when vertex form wouldn't be a great way to solve it, right? So just focus on, okay, it is a good time to use vertex form. How would I solve this one once I have vertex form? Does that make sense? Like you were talking through here, oh, if I get vertex form, but do you want to get vertex form in this case? So don't worry about it. I'm not talking about solving it there, right?
Like once where you realize, oh, this.
Yeah, okay. Oh, vertex form is going to be ugly because I'm going to get a fraction. Well, then we're not going to worry about how to solve for vertex form from that point. Does that make sense? And one of the things that I would talk about to differentiate vertex versus factored form, because setting up factoring, setting up vertex form, setting up quadratic form, they really take about the same amount of time. But the zero product property is so easy to use. That's why I like factoring a whole, right? Vertex form, if we can get, and I talked about one of the groups, if we get an integer, which is why one of the groups said, oh, it's an even number, right? We can't get an integer h unless it's an even because we're dividing by 2a. Does that make sense? So that's a discussion point that I had with one of the groups. But yeah, and once you started establishing, oh, factoring is good here, efficient, you don't have to go through yes, but it was the most efficient because of zero product property.
You know he is not village. I don't know what they're saying. Not going
The rotation,
do we change the
but I like to just rotating through the whole way. I think that works out really well, just having one round of multiple rotations. But you let me know, hey, if you agree with that, that's what start solving. See if the thing works. That's what I would start to do with those instructions on the rotation. Good morning, Kason. Huh? Oh, sorry.
Should we erase?
I do.
Miss Bauer, should we erase?
I don't know what you just said.
I got me all
Make
of
sure
it.
he emails me. So that I know that you're there. I'm still responsible for you. Yes, new seats. New seats. Good morning, Nicole. Yeah, you are. Good morning, Kennedy.